This is the 5th grade weekly word problem for November 14th through 17th. A water tank is filled at a constant rate. After 36 minutes, there are 648 gallons of water in the tank. How many gallons of water flowed into the tank each minute? Okay, so I'm going to go back to this. When it says a water tank is filled at a constant rate, that means the same amount of water is flowing in every minute. Okay, so after 36 minutes, there are 648 gallons of water in the tank. How many gallons of water flowed into the tank each minute? Okay, so they're giving us a total amount that has flowed in to the tank, and that the same amount flowed in every minute for 36 minutes. The first thing I'm going to do is write an answer statement. So if my question is how many gallons of water flowed into the tank each minute, my answer statement is blank, or gallons of water flowed into the tank each minute. Okay, so I'm looking for how many gallons of water flowed into the tank each minute. So I'm going to make my bar model, which is sometimes called a tape diagram and sometimes called a strip diagram. And my bar model, what I'm looking for is how many gallons of water flowed each minute. So I'm going to write on this side, what I'm looking for is gallons per minute. Okay, and now I'm going to make my bar. And I used to write total on top, but I found out that really the total, when you're writing your bar model, if they give you a total, you're supposed to put it at the end of the bar. So they're giving us a total of 648 gallons. Okay. And the other information that they're giving us is that it was constant and it flowed for 36 minutes. So I need to see how many 36s go into 648, because that will tell me how much each minute, how many gallons of water flowed into the tank. So I know it's for 36 minutes, so I'm putting a 36 here, and I could, I could put 36, 36 and count until I came up with 648, but we're not going to do that. We're going to divide. So I could be thinking of how many 36s are in 648. So for my diagram, I'm just putting a couple 36s to show that I'm finding out how many 36s are in 648. And this, when I find out how many 36s there are, will be my answer. So really my equation is 648 divided by 36 equals what? Okay, so this is a division. We have a total. They're telling us how many minutes. We have to find out how many 36s go into 648 to know how many gallons flowed in each minute. So I'm going to use, let me just backtrack a minute. This is not my strategy. This is my model, okay? It's a bar model to show me what I need to do. This is an equation, okay? This is an answer statement. Now I need to think of what strategy I can use to divide. I'm going to use the partial quotient, and sometimes we call that the hangman. And having this nice piece of graph paper helps me to set it up nicely. My divisor goes on the outside. My dividend goes on the inside. And remember, what we're thinking of is what number I can multiply, what factor I can multiply 36 by to get as close to 648 without going over. And I'm trying to look for numbers that I could do in my head. So if I know that 36 times 1 is 36, and I know you all know that, then I also know that 36 times 10, okay, 36 times 10 will give me 360. So I'm going to start with that, and I'm going to put my 10 here to remind me that I'm multiplying, I'm having 36, 10 groups of 36, and that's going to be 360. So now I'm going to subtract. 8 minus 0 is 8. I cannot take 60 from 40. So I have to go to the hundreds. I get 100, which is the same as 10 tens. And so now I'll have 14 tens there. 14 minus 6 is 8. 5 minus 3 is 2. Well, I can't do 36 times 10, okay, because that would be too much. I don't want to keep just subtracting 36. I could do that. But the other thing I could do is try to figure out, well, okay, if 10 is going to give me 360, why don't I just try 36 times 5? And over here I'll work that out. I'll use my area model to show 36 times 5, and I'll see if that will work. So I have 30 times 5. I'm thinking 3 times 5 is 15, and I add a 0. 6 times 5, so I could put that here if I don't want to forget what that box is showing. 6 times 5 would give me 30. If I add up my 150 and my 30, I'd get 180. That would work. So I'm going to do that. So I'm going to put 5 times 36, 5 times 36, and that was 180. Okay, so I subtract. 8 minus 0 is 8. 8 minus 8 is 0. 2 minus 1 is 1. Alright, so I know that 5 times 36 is 180. I'm thinking, why don't I try 36 times 3? Okay, so I'm going to try 36 times 3. So I have all this room here. I'll put another area. I'll do it 36 area model times 3. I said yes. Almost forgot what I was going to do. 30 times 3 and 6 times 3. 30 times 3 is 90, because 3 times 3 is 9, and add the 0. And 6 times 3 is 18. Ooh, this looks good. I think I have the exact number. 8 and 0 is 8, 9 and 1 is 10. That worked. Okay, it was 3 times 36. And I kind of squished that. I really shouldn't have. These are called my partial quotients. They're part of the answer. So to figure out what number my quotient, my entire quotient, I have to add up my partial quotients, and I have a 10, a 5, and a 3. 5 and 3 is 8, plus 10 is 18. So my answer is 18, and remember what that 18 stands for is 18 gallons of water flowed into the tank each minute. Okay, so again, I read the problem, I wrote an answer statement and left a blank for the answer that I was looking for. I made a bar model To represent what I was going to do, I wrote an equation, and then I solved the division problem. Okay, all of those steps to solve one problem.